We're back. I've been a busy person for the last couple of days, probably longer. I've been working hard on this report for you guys. Hopefully this is going to offer some insight to people. I'd rate this as an intermediate level. So like if you've got some experience with training or you want to learn more, you're going to get a lot out of this. If you've already trained like 500 models, you probably know a lot of what is here, but you might find some interesting stuff just by reviewing the Figma. The link will be in the description. We're going to spend a lot of time looking at that because I've basically already done all the work, so we don't have to like wait for generation time. Right now we're looking at the page. This is my test model for training with Cascade and just training, like trying to fine tune the tune. So the article is linked there. Full data set is on GitHub, and the Figma link in here somewhere is actually out of date. Oh, it's not here. Okay, maybe it's in the article. The point is, this is a new document I've put together. So we're going to take a look at that. Obviously, everything we're talking about today is OneTrainer. You can join the Discord. They've got a load of really helpful guys on there. I got a lot of information that I needed to put it together. So thank you to everybody on the OneTrainer team and everyone in the community. You guys are awesome. And then what I'm going to do is I'm just going to take you through what I've done. Something I'd recommend is just making a simple spreadsheet. And if I just make this a little bit, there we go. So I was doing it with ADAFACTOR at first. So I started off with something I know worked, but obviously it was for a much big, so I had to adjust. I had to do a lot of adjustments. Had a moonshot, which I released. So it's explained here, like what these actually are. So 16, 1, 32, 1, 32, 8, 32, 4, and 64, 1. These are all trained on the 3E3 with ADAFACTOR. Okay. And so what you can see here is basically me messing around with the various different settings. Here's the ones at the bottom basically got released, pretty much, where the convergence points were. Okay. And then I did a bit of experimentation with different learning rate of 3E2. So that was my AK16, and then 3E1 for the AK17. I believe that one came a version, actually. So got that one. And something that was interesting, which is something I noticed here, was we got this early convergence of 660. A lot of the time it was about 1188, and I did have a graph which I can show you, which sort of points to that. It's very interesting stuff. Anyway, we're going to plow through. So after 3E1, I started investigating comparing it with PRODIGY, which is, I think, a little bit better than ADAFACTOR, but it uses more memory. So, you know, this was quite heavy on the requirements, but you got good results. And I think if I applied it to Excel, it probably wouldn't use anywhere near as much memory. So we're going to have a look at that in future, but let's stay on the course. So what's actually going on here? Well, every time I make a new one, I change one thing. So I think it was around here we started actually saving them every however many, which is a setting you can do. It's pretty easy. I hadn't had that turned on yet, so I was just plowing through. And after this point, I pretty much set a higher epoch. So I set it way higher than I think I need it, but I save it every 4 epochs. So then I get like a big range, which I can then just run the same image in the same seed. I can get a feel for whether it actually came out nice or not. And then I come back to it and I keep going. I change one thing. I experimented with different numbers of repeats. Obviously, we've experimented with trying to find different convergence points, different types of ranks and alphas. And we're only changing one thing at a time. That's the method. Just change one thing. See if it made it better, did it make it better or worse. It's sometimes not so easy, but I generally try to get a feel for it with a low rank and then increase the rank and try to get closer and closer. We'll see that in a minute though. So we're going to get out of the spreadsheet in a minute. When we got to PRODIGY, it's pretty much just the same process. All I'm doing is adjusting different values. You can't see what the values are here because I've started noting them into the worksheet. So we'll have a look at some of the results first because, you know, you get a feel for it. So these are some of the later results. And it's taking an image for Clip Vision along with my model. And if I was just to scroll out a little bit, you can take a look at this at leisure. The link is in the description. But basically, one thing I noticed was that the early models tended, because this is a skeleton warrior, you know, if we hadn't already covered that. So let's just start at the beginning. So I'm going to put some chapter markers in here. So, you know, if you're just watching along. Anyway, so here I've noted down that first section, which I showed, and I've written in where I thought the convergence point was. And I just put it in bold. So, you know, for the initial models, like I said, it's overtrained, and you can tell it's overtrained because it's doing all this weird stuff. But it did make a good model that was worth putting out on that early days. And then here again, I've sort of figured out how I can reduce it, because it's weird. You get a really good representation of the character, but you can kind of see it's cooked. You can see this mottling. If you zoom out, it's a bit more apparent. You can see this kind of like, not bleached. It's kind of like a cooked look. And so I started thinking, well, I'm just overtraining these. And this is when I was starting to reduce my learning rates and stuff like that. We get on to AK4. AK4 is 16.1. So here now I'm just going up to 80 to make sure I'm right. And I was right. You can clearly see the cooked image there, right? And these are 3K images, but I think they end up being thumbnails. So, you know, it's best to look at them like this. They're not the full image, all right? But you can see them well enough to compare them like this. So AK5 would be 16.1. So I'm still messing around, basically. I'm just messing around until I get down here, because I just keep on trying different things. And I get down to the difference between like 32.1 and 64.1, which is AK10 and 11. So if I just go down to there, and you'll see that, you know, AK8 got picked as a release, I think. Yeah, okay. So I picked AK8. Okay, so that would be an early one. And that one came out as version 2. And then what we did was we took the next two. So let's just have a look again. So 10 and 11 are 32 and 8. So you can see that here. Got the 32, and then there's the rank. We've done rank 4 as well. So we take a look at 10. This is 32.1. And the weird thing is about it was you were getting more detail, but it was doubling the swords up and doing all kinds of weird stuff. I did find that by changing the resolution, it got a little bit better. And it's funny. This is a good example. So this is more like, I would say, high quality, right? It looks like a better image, but this is actually the better image. So it was consistently giving me, like, the early image was more like what I was training. Okay, so that's going to be a theme that's going to keep coming up. So even here, this is actually too far. It's somewhere between here and here. And this is why I had to just keep on. So this is all about different ranks, and it's overtrained. And this is how I can prove it too. So like, that's okay, but actually it's not very good when you go to use it for stuff. It didn't actually work when you actually come to use it to generate images, like with image to image or vision. It just didn't really like what you were trying to do. So anyway, we moved down, and the initial ones are just here, for example. So what I've done is I've gone, well, hang on. What if I have a data set with more images? So this data set has 41 images, and it's just a bunch of abstract chaos type stuff. And so again, what I'm doing is I'm looking for the convergence point. Now you can take a look at this at your leisure, but I pretty much reckoned it was about here, 18. Now, as it turns out, I think now it's probably more like down here somewhere. It's probably more like 8 or 10. Just from what I've learned is that I was constantly picking the convergence point that came late. And in fact, let me just skip down here. I can show you the graph. So here's the thing, right? You can see that they were always consistently hitting this low point, 11, 18. But actually, the best models were coming in around here, around 660. And when I say the best models, I mean, these were more accurate to ground truth. But if you tried to actually prompt them with anything else, they couldn't do it. It was like, it only understood the universe of what you've trained now. Even without the trigger, and I can show you what I mean here. Is it there? Where did I do that? So here's what I wanted to show you with the prompting. So the interesting thing about the second data set is it actually contains 4 different captioned styles, I guess you could say, in the same type of style. So these are the 3 triggers for that, and they're contained cleanly in there. You know, you can see there's 3 different aesthetics of this abstract chaos style, and they're separated by their triggers. But the interesting thing is I actually made a mistake. When I first ran the test, I forgot to change the prompt from the skeleton warrior, right? And this is the thing that made me sort of go, hang on a minute. So if we take a look at these up close, it started going, oh yeah, skeleton warrior. This is what it looks like from the model. Skeleton warrior, abstract chaos. So now it's giving me abstract chaos, even though I didn't actually ask for it, and continues to do that. And it's a mix of all of the styles together. Okay. And it's kind of stepping through them as it gets more and more overtrained. And what I realized was that this is why the early models are more elastic, because here it's still responding to not being triggered. But when you trigger it, it gives you what was trained. But if you go too far, now it only gives you that. So it's kind of like bleeding into everything. So that's an interesting one. ADAFACTOR versus PRODIGY. So we may as well just show that to see what I'm talking about. So looking at the ADAFACTOR, it's good, but it's kind of coming out a bit overdone. It's like, it's overdone, basically. This is probably the best one down here at the low strength. But what I was finding was that if you try to do stuff with them, they're just not as malleable. There's better examples that we'll get to. But like here, it's a person, a woman in some kind of like sci-fi outfit. And so it's done a woman in sci-fi outfit. Quite consistent faces as well, to be honest, when you're not actually using a face swapper or anything. And then in the background, we've got that's the model. The model's been taught all of this sort of Geiger-ish biomechanical stuff, right? That's what that prompt. Something out of a sci-fi world. That's what that was. And then just going back to these quickly, it's like an abstract art palette with a person with an anime girl. And then it's going to make a kind of, I think we've done a prompt, raw photo. And again, it's not really a photo, but it's like sharp cartoon. The images are much better than this. I don't know why it's cooked them so badly. Probably because there's so many. So anyway, from the abstract chaos, what I did was I picked an early epoch and I picked a late one. So, what have I missed? Yeah, so we picked that, and there's the examples of that. And then we get on to the good stuff. So the data set's on GitHub, the articles on Civit, and the models are on Civit. I'm going to add the models that we're about to look at there too. So this AK10, AK16, AK17, those are the comparisons for 3E3, 3E2, 3E1. So, sorry, 3E3, 2E3, 1E3. Anyway, I don't know. The point is I'm backing off the learning rate a bit. I'm just going to plug on. Editor, cut that out. So here we have convergence at 20. I would have hoped that you'd probably agree with me, because look, it's too generic here. It hasn't really learned it. And then here is the first point where it's actually seemed to learn it. But as I said, I think, yeah, these are all ADAFACTOR. And in the end, I went with PRODIGY. So, all right. So what we've done, and it's very strange as well, because you could kind of see how it's just, that's almost like what it's not. It has learned a bit. It's learned the hair, but it already was making this kind of thing without the Lora on. When you start to see the difference, because it's like a watercolor style. So when you start to see that mottled background, it's almost like parchment. And I thought this one was pretty good, but the sword position is like exactly what the original model was. So I knew it hadn't actually trained yet. I think probably this is pretty good as well. See, it's so difficult. It's so difficult because you'd think, oh yeah, this is pretty good. And to be honest, maybe I was picking too late because like I said, the big thing I learned was this is too late. I should have probably picked an earlier one like this one, because there's not really much difference between that one and this one. This one is got more hallmarks, like it's got the gloves holding the sword in the right place, it's got the hair, it's got the background, it's got the swirliness. There's a lot of stuff going on here which is from the dataset, but this has most of it already. And I reckon that when you go image to image and try to actually transform and apply the style and do things with it, put the character in scenes and stuff, this one is going to work better, because the problem was this wants to make this. It only does this now. So it's weird. I used to call it overfitting, but that's something else. That's like something that we looked at over here. That's overfitting. Okay. So I don't know what it is. It's overtrained, no matter what you call it. It's too much. It's too many steps, basically, is what I've worked out. And so I started, when I did the Prodigy, I started saving the every single one. So there's like 200 models here that have been tested. I put them into a grid because we're saving them every 4 epochs. The full training config, it's in the Discord, but what I'm probably going to do is put the file somewhere somehow. I might even put a paste bin of the config that I landed on in this video description, something like that. It's not really very easy to give you a preset, let's say. I suppose that's an option, though. Regardless, we went to the GitHub for Prodigy, and then we just read what they recommended from the community, and what they recommended with training diffusion models was set safeguard to true, set bias correction to true. The beta, I actually put that back to 999. So it can be 999. It doesn't have to be 99 for beta 2. You can go that extra decimal there. I also tested on someone else's recommendation 1E07 for the initial D, and we'll get into that. That's coming up later. We also tested D coefficient, but I found it's best to leave it at 1 with everything else that I'm doing, for Cascade at least. Some people were saying give 2 a try. 3 just completely was just just destroyed itself. So I believe it's a multiplier on the learning rate for this system, but that's probably an oversimplification. The point is the default's 1, so all you had to do really was change it to Prodigy. You have a learning rate of 1 as well in the screen before this, because it's like an automatic. It's trying to do it for you. It'll automatically change the learning rate to what it needs to be. That's the whole point. Anyway, so the differences here are always one thing changes, all right? And if it was a failure, I just don't keep it, and then we move on. When I say tank 50, that means text encoder 50 epochs, all right? And I haven't changed that for the whole thing. I've just left it on that. So it's matching. So I'm cooking 50 at 50 with 50. And I don't really know how to break that down. Somebody said try doing 32-0, and that was actually recommended in a guide. Don't. They said that the 1 is a dividing the rank, and they may well be right. So then it would be 32-32, right? No, it doesn't work. That's fine though. It was worth trying. And then we've done various other things to see what the effects are going to be, and then we can see those in like a big gradient with the same prompt and seed for everything. So that's how we're going to do it. The last 2 models were done at the higher rank of 64.1, so they're basically the same as the one before, but with the change. So AK27, no, we're not even going to do that one. There we go. AK28 32.1, AK30 is 64.1, and then this is that initial D I was just talking about, where it's a slightly different rate. So with that being explained, and bearing in mind you could just read this up at your leisure, I'm going to dive in. So from here, and we're going to go real quick because I hope that it's clear. You can see that we start off with like a blown out image, which gets a bit better, bit better, bit better, bit better. There he is. There's our character. And then, oh, went a bit weird, got even better. And so that's the one I picked. But what I've done is I've saved early version for every single time. Okay. So this one was coefficient 2. That's what the AK20 is. 22 is coefficient 1. They're exactly the same. The next one down is 23. What is? Yeah, that's when we actually changed these. So up until here, we've been using the defaults that came with just changing Prodigy, just turning Prodigy on. And then I read this and I changed safeguard warm up, bias correction, weight decay. Okay. And the bias 0.99. So these two are using those improved settings. Okay. So then we've done coefficient 1 versus coefficient 2 again. And it was quite interesting because, like I said, in the first 4, nothing's learned. And then for coefficient 2, it's kind of blown out. Coefficient 1, it's not the right character. It's a skeleton warrior, but it's not our character yet. And then in this one, he's kind of got like a giant head, which kind of gets better. You know what I mean? But then we get these weird sword hilts on his back, and it's kind of a hood. But I picked that one anyway for the early because that was the best early I could see. After here, we've got extra weapons, double swords. I don't know what that is, you know. And so this one ended up being the best. I thought the closest to the data set is what I was looking for. That's what I was looking for, right? And that's a key thing because when you're doing this, you're thinking, oh, well, I'm obviously trying to train until it looks like what I'm training. And that's true. But then you end up making only this, which is less useful, I think, than being able to make something that looks pretty much like it, but it can transform. So anyway, this was coefficient 2. And then here, what I've done is I've changed that. I've added that 0.999. So now we're back up to the normal range. That's the only thing that's different from here now. We've added that extra decimal in and then back to 1. So you could compare 23 and 25 because they should be the same. And as you can see, adding that extra 0.9 did make a big difference to the actual results. And they should be identical because we've only made one change. And I can do 2 runs and get the same model. It's not like they change from time to time. Now, I like this one because it's actually learned something from the background. In a couple of the dataset images, there are these kind of moths flying around, and bats and things. And that's generally never been learned. So that was interesting to see it. So I had to pick that one for the precise. But to be honest, this one was the most accurate earlier one. And they tended to keep coming in the same spot. If you see, this is that 1188 I was talking about. And then this is that earlier bit here. And it's rough because I haven't got the steps exactly on that, where those graphs dipped. And to be honest, I don't know how useful that graph is really, but it does seem to correlate with little islands of stability in the, in what's going on here. So here we go. Look, 32.0, nothing. So here's an example of a Lora not training like at all. So yeah, that didn't work. I think that what you do is if it's like a multiplier of the learning rate to like dampen the learning rate, 0 just means it's not going to learn, right? So it makes sense. It's just the documentation was unclear. It seemed to imply that 32.32 would give you 32.32. But actually, it just doesn't do anything. Anyway, so next what we've done is these are now, here we go, we're nearly done. So we're getting on to the final models which I trained. So I decided to do a 6432, which was recommended in a Rentry. So I thought we'll give that one a blast. Okay, and that one did produce some good results, actually. So we got a nice early, and then we got a precise, and then things started to kind of explode a little bit. So I don't know, but And then finally, we did a 32.1 with a 0.06. I'd been using 0.0357, which was the old triangular offset noise that people used to recommend, and I used it a lot. It's a good number. I don't know if it's really triangular. Probably not, but that's what everyone called it. So this one became V6 early. I tried to label things so that you could see like what candidates, because that's the other thing about training. You end up with hundreds of models, and then you'll end up picking a winner. And I found that this is like the result of all the research I did with, and this is where I started to notice that we get a really high quality output. And it is straying from ground truth. There's no spear, double-ended spear in the data set. So it's starting to sort of do its own thing here. And that's why I ended up picking this one. But again, it's so subjective. Like you might pick a different one. It depends what you think the hallmarks of your model are. But regardless, somebody said to me, oh, there's been a OneTrainer update. So what I did was I retrained it, but took the opportunity to do it at 64. So it's these two are basically the same. The only difference is I increased the rank to 64. So V6 early and V7 early are exactly the same. They just use 32.1 or 64.1, right? And then this last one was somebody recommended I should try out the initial D value. So I decided to test that against V7. So that's the V8. So the ones I actually recommend for like messing about with are V6 early, V7 early, and V8 early. But we have also got mid, V8, V7, and V6. So that way we can actually make a nice grid and check out the difference and see which ones, which one was actually the correct one to pick. Because that's how you do it. So here we go. So yeah, this is literally the results phase now. So just to briefly overview this, the method is you get your data set, you train it, and that gives you a baseline with the default settings. You then change one thing and train it again. You check the result. Is it better or worse? If it's better, you keep the change. If it's worse, you go back to the last change. And then you run through all the settings and do a lot of reading. Okay. And that's why I'm trying to sort of show you this so that you can get a better idea for how to do it. I'm trying to stray from here's my config, which I will provide for transparency. You can see my data set, you can see my config, you can repeat this training, right? But that's not the point. The point is knowing how to train any model with the same procedure, which is make one change, test it. Was it better? If it was, great. And the weird thing I'm trying to point out here is that a lot of people only look at this. They only look at the text to image. And the worrying thing about that is that you end up with a really accurate model. Like if you go check out the ground truth by visiting the GitHub where the data set is, you can download it and see. It's like a watercolor skeleton warrior, okay? It's nothing crazy. There's only 11 images, right? So it won't take any time. You just look at it. Every caption is the same, okay? So we can't blame the captions, right? It's just tag, style, a skeleton with a sword. And I did say, oh yeah, the sword does have red hair, but that's because what we've done is we've trained this type of red hair, which is kind of like blood streaks. And so then if his sword has red hair, guess what? He's kind of swinging around this bloody sword. Anyway, right. So we've picked all of our winners, or rather we've got candidates. So I'd save it as like this one here, AK23 early, AK23. Okay. So then we come to the results. So that was I just wanted to make sure, because this process, you can do this with anything you're training on any model. It's not about Cascade necessarily, even though it is. I'm going to do the same thing with XL because I didn't use PRODIGY before this. And now I want to see if I can get better results from XL with PRODIGY. So I'll probably be back with another one of these long form videos. Right. So it's time to take a look at some results. So I just want to explain what I've done really so that you can look at it at your own leisure and know what you're looking at, because there's a lot here. So with the early versions, which I've already released, that was just done with ADAFACTOR at a high learning rate. Okay. So that's what this level is here. All right. So same prompt and seed. We've used a source image of this lady here that I generated in one of my 2.1 models, I think. No. Yeah, no, she's an XL model. And as you can see, as soon as we try to do image to image, 0.5, yeah, it's kind of doing it, but it's just exploded. As soon as it got close, it just couldn't really do it. V3 did a little bit better, right? And then the later trying to mess with different ranks, that helped a bit. But to be honest, it's not what you're looking for. If we take a look at a different source image, so we've got this lady here, right? The first image I put out works. It does convert the style. But you could say, oh, well, it's just a skeleton. It's not the skeleton. The hair has been the hairstyle is kind of converting. But as you can see, it just explodes as soon as you get up to denoise 6. So this is what I'm trying to get across, is that when I was training with ADAFACTOR, yeah, sure, I could train and make my character in text to image. But as soon as I try to do some blending, mix it with another Lora, load it on top of a different checkpoint, anything like that, it's kind of rigid. And you can see it as we go into the next section more. So AK16 and 17 are the 2E3 and the 1E3. So this is reducing learning rate with the ADAFACTOR. And as you can see, it didn't really help. Yeah, it didn't really help at all. You could say that actually it got worse because there's less stylization being transferred and a harder border between coherency and explosion. So it was no better. So we get into the PRODIGY stuff, and consistently the earlies are more malleable. So if I take a look here, it's not really doing much except for a medieval theme. All right. But then you get to the early and it's actually starting to turn it into the character. Now, I never removed the word sword from the prompt, which I probably should have. So that's my fault that the swords keep appearing there. But if you don't have it in, and we won't later, you'll see that when you make it too strong, because that was part of the training, you always get the swords, right? So that's another thing. But as we move down 24, so just a brief reminder, we don't really get to the good settings until 27. And then we adjust the noise at 28. So if I'm down here now, here's 27 early. So it's the last 4. So as you can see, the early explodes later. The hard version barely stylizes at all. Okay, yeah, it's got the theme, it's made it a bit darker. It's an anime style now, but it's just exploding before it can't transform her into the character. It can only try to make him out of that noise, which isn't, you know what I mean? That's early image to image. That's not what we're used to. So again, the early version, right? It's doing it. It's turning her into the character, which is what you want. If you've trained the character, you should be able to load up any image, put it at 0.5 and see something between the two with the right prompt, which is what we're testing here. We're testing the elasticity of the model. Can it actually be used to transform stuff, or is it just a photocopier? This is where we're up to now. Carb V6 early improved elasticity, transforms to style without exploding. Late version, improved quality, but less accurate. So it seems like a trade-off. We can overtrain our style, but at the risk of it not being useful. But here was the twist. If I went to a photographic style, suddenly the early version was actually exploding. And then the photographic version almost got there in an interesting way. All right. Now, that's not really, I don't think that's really as useful as it might seem. Still think the earlies are more useful, but I'll probably end up releasing both of them just to see what people think, because you don't know until it gets out there. Anyway, so now what we're doing is we're taking a slightly modified prompt. So one of the trigger words in the Lora is demonic looking skeleton. We trained the red hair, and assassin carb style is allegedly the main trigger. So anime is the qualifier. It's a woman with red hair. So here we have an anime woman with red hair. And then at 0.45, okay, it's making our character. And this is with the ADAFACTOR, these ones. We're back to V5. There it is. So version 5 is 32.1. So version 5, I think, is an ADAFACTOR. I'll update the document so that it indicates that a little bit more clearly. But essentially, we're comparing all the models that we've trained. So we're going to go from V2 all the way down to V8 with the mids and the earlies, and then you'll be able to see it. It's like looking at a slideshow and you can just immediately tell. So I'm not going to go through every single image here, okay, because what it shows is that as the training was refined, I got better and better and more coherent results until we end up with the V8 and the V7. Those are the best ones, basically. But I do like V6, which is only a 32 rank. So it's basically, it's the same thing, essentially. So V6 is 32, V7 is 61, and then V8 is using that modified initial D. Okay. And it's up to you, really, whether you like that. I mean, I thought it was cool how we were starting to get this stuff popping out. Okay. This extra skulls popping out. All right. Oh, yeah, and this is what you would have got if you just ran the prompt without the Lora. So I included that. So I've included the source for the image to image and what you get without the Lora. And then we run through at various denoise strengths, okay? So what's consistently obvious is that the early versions are more, well, actually, it's not so much there. The mid is better there, actually, saying that. But I would say, generally speaking, if you look at it, the early versions seem to be better for what I'm using it for, right? Which is transformation. Because as I say, yeah, this is cool and all, but we're just using, that's all model memory stuff. Whereas the idea of the skeletal torso and all of that sort of thing comes from the character that we've trained. And so you can see that being exhibited in this, but it's too much. It's too much, right? So this is much more usable. It's just transforming the character rather than just blowing it out over the top of whatever color shape was there. So that's what I was trying to show. But I won't bang on about that. So here's some photographic. So there's some photographic results, and we get some good images out of there. Like I said, it's worth browsing over in your own time. The best of it is the models comparison. So I started off with vision source. This is just a breakdown of how this is done. We use one of my workflows for Cascade, which is the Cascade vision, image to vision. I think it's the Argus workflows. And I've just used a graphics swatch with a character and the prompt raw photo of, and that's just the trigger. I actually misspelt it and put a demon C for some reason. I don't know why, but I stuck with it. You make one typo and get halfway down. You can either do it all again or you can just roll with it. So we roll with it. But yeah, this is the first version that came out. The second, the third, the fourth of it. So these ones were already released. All right. And like I said, they're producing good images. The V4, this is what made me retrain at 64. It just managed to capture a lot more of the style when I actually use it. And so that's why I sort of saved that for last, really. We did a couple more experiments with ADAFACTOR, and I think I managed to get it a little bit better. I think it got better, but it wasn't it wasn't really working. And I think really we probably should have just gone with that. Let's go with the first one. It seems like everything's horribly overtrained, but then again, everyone uses different settings. But yeah, so anyway, we get to the earlies, like I said, are the best ones. So, and I think 32.1 is the smallest file size. So certainly this one's going to be popular, I think. I think that's a good one. The V6 early is quite useful. It's doing the good stylization anyway. Like I said, if you look at the final V6, it's actually stuck with the woman. It's really interesting because it's almost like the character's gone, basically, and it's just got the person from the you know, from the input is basically taken over. With no Lora, it looks like that. So it's still an improvement and closer to the aesthetic that's been trained. But anyway, and we see this continuously, like V6 early. Oh, look, it's our character. V7. Uh-oh. And you could, like, it's not bad, but it's not what we trained, bottom line. So again, with the V8 early, bang. It's there he is. There's the character. I mean, you could argue this is a little bit like, you know, it's different because obviously we've combined it with the uniform and the abstract stuff. So we get some really cool images actually out of this. But that's what I'm trying to point out is that consistently, it's the early model. And then this is the part that's probably the most fun. Because it's just a whole bunch of different prompts and images, and all I've done is I've locked the seed and I've gone through every version. And so then you've just got a massive grid. This one is of particular interest because it shows what happens when you get the resolution wrong. So I was using 3072 by 3072, and it's making images, but this one's way better, which is just 3072 at 16:9. And then consistently, no matter what well, actually, except for that model, that I don't know what happened there. I think I might have had to restart my computer at that point. If I go down through here, it's consistently, I mean, I kind of like that actually, but this is also very cool. This is so bad. So there's some really cool images in here. But the one thing that remains consistent is the earlies are always featuring the character that was trained more prominently than the lates. And the weird thing is, as a guy that's trained loads of models, I would instinctively always have picked the late one. And I've never really looked at the early dips in the learning rate to see what's going on there. Generally, I discard a lot of the lower learning rate stuff. And this could just be Cascade, learning quickly, all right? So I don't want to make too many assumptions. But this actually, there's another one. Oh, yeah, so here's an abstract version. So I've used a couple of abstract. And like I said, it nails it on the early. It's good on the late, but the early features the character every time. So the biggest takeaway from this is investigate your earlies. And in fact, here's another one. So for this one, I said holding a gun. Well, it's a sword. That's a gun, but she's not holding it right. That's a sword. That's a whole bunch of gun sword things. That's a sword. That's a sword and it's our character. That's a gun and it's a girl. That's a sword. That's a gun, but she's just got demon eyes. Good gun. That's a really good gun, actually. Good gun, just demon eyes. You know, the character isn't coming out now. And so I tried to make the prompt a bit stronger. I mean, these look really awesome, though. These do look good. So I looked there, and again, at the early, she's holding the gun, but she's not the character. On the late, it's the character. So it's not like a rule. I think it depends on a lot of things. Here's a character holding a gun. Almost. That's close. And so, yeah, we went through a variety of different things, really testing it hard to see like how this elasticity is what I'm interested in. Because if you want to train a character and then you want to put it in lots of different situations, it's no good if it can only make the source images. So again, here we are trying to go through all the images. Doesn't do very well with the house thing, but as usual, when you get to the early versions, the character somehow becomes more prominent. It's interesting. So it's just something to think about. What I've done is I've put all of the links in the description, as I've said multiple times. Some really cool experiments with architecture, and just got some June 2 promotional screenshots. It's a shame the resolution's been totally cooked from a lot of these, but what can you do? And then I got some really nice input images from a friend of mine. He's given me some nice ones. Now, there is one thing I have noticed. For anybody that's bothered to watch all the way to this point, there's a weird thing with Cascade where it makes a weird texture on things. And you can always see it. And I don't know if it's because the inference code, or if it's the way the model works, or if there's some kind of VAE improvement. I don't know what it is. But what I do know is, or what I think has helped, is, as it says on the model card, don't use a negative prompt. If you use a negative prompt, it seems to put a weird texture on everything. It might, maybe it just does it anyway, but it seems to be not as bad if you don't use negative prompts. So that's just something that I noticed. This is not bad. I mean, if you want, because the thing is, I have to keep in mind that I was training watercolor, but on the other model I trained, it was equally as bad. And if I was to scroll in, it's more immediately apparent. Is this 1-to-1? Useless. Right. So the weird thing is that the frame isn't too bad. And it does kind of look like paint strokes a bit, but there's this strange noise on it. Like here, there's a good example. Some weird stuff going on. Now, this could just be me. This could be my compression or the way I'm using my workflow. You know what I mean? There's loads of workflows out there. Maybe there's some setting, like maybe I got a CFG too high. So anyway, what we're going to do is leave it there. So all the links should be in the description. Come and join us on the Discord if you want to ask some questions. Go over to the OneTrainer Discord. Tell them I sent you. They're helpful people. They're so helpful. I've had a great time hanging out over there the last couple of days. And I'll see you in the next one.